A space shuttle is made up of 739 critically one items. Each critically one items must have 99.99% reliability, meaning that the probability of failure is 0.0001. Determine the probability that none would fail. So there are 739 of them, and none fails means all work. So all seven, so the probability of each one working is 0.9999. So you would have 0.9999. That's the probability that each one works. And we want all 736 to work. So we multiply this by itself 736 times, which means you raise this to the power 736. And you get 0.929. Probability that at least one would fail. So at least one fails means, so again, let's carefully write it down. Probability at least one fails. 1 minus probability none fails. None fails means all work, and we just calculated that all work is 0.929. So that would be 0.071. The principle of redundancy is used when system reliability is improved. Assume that your alarm clock has a 0.89 probability of working on any given morning. What's the probability that it will not work? So if it's 0.89 probability of working, then it's 1 minus 0.89 of not working. So 1 minus 0.89 is 0.11. If you have two such clocks, what's the probability that they both fail? So one fails is 0.11 and two fails will be 0.11 times 0.11, so 0.0121. With one clock, you have 0.89 probability of being awakened. What's the probability of being awakened if you use two clocks? So this is a very interesting question. You need to think a bit more than it appears. So to be awakened, you're not finding the probability of both clocks working. If that's the case, then it's very easy. You just do 0.89 times 0.89. So that's not what they're asking. What they're asking is, what's the probability of being awakened if you use two clocks? So if you use two clocks, then to wake up, you don't need both of them to work. You just need at least one of them to work. So actually, it's a very roundabout way of saying what's the probability of at least one clock works. So we know we do that through complement. So at least one works would be probability 1 minus none works. And we just calculated the probability that none of them work means both of them fails. That was part B, 0.0121. And now when I subtract these two, I get 0.9879. That ends the section.